Have you ever heard Python programmers throwing around words like classes and objects and just kind of nodded along, feeling like you missed a pretty important memo? Well, you are in exactly the right place. In the next few minutes, we're going to take all that jargon, break it down, and turn it into a simple, powerful tool that you can actually start using right away. So let's start with the big question. Think about it. A program is just lines of code, right? It's just text and logic. So how on earth does it represent a real-world thing, like a person, a car, or a bank account? The answer to that question is exactly why classes and objects were invented in the first place. And here's our game plan. First, we're going to lock down the core idea, the difference between a blueprint and a real thing. Then we'll actually create an empty blueprint, use it to make some real objects, give those objects their own unique data, and finally, teach them how to do stuff. By the end, you're going to have a whole new way of thinking about your code. Let's dive in. Okay, before we write a single line of code, we have to get this one single idea straight. It is the most important distinction in all of object-oriented programming, and it all boils down to the difference between a plan and the thing you actually build from that plan. First up, we have the class. A class is just the blueprint. That's it. It's the rulebook. If we want our program to understand what a student is, the class is the document that says, okay, every single student must have a name, and every single student must have an age. By itself, a class doesn't do anything. It's just the instructions. The object, on the other hand, that's the real thing. It's the actual student that we create using the rules from our class blueprint. This is the thing we can actually work with in our code, a specific student, like Ali, or another one named Sarah. And this little comparison just nails it. A class is the blueprint. The object is the actual house you can live in. The class is the recipe. The object is the cake that you can actually eat. And for what we're doing, the class is the rulebook, and the object is the individual student. See? You can't live in the blueprint, but you absolutely need it to build the house. All right, enough theory. Let's get our hands dirty and see what this actually looks like in Python. We're about to create our very first super simple blueprint for a student. And you know what? The code for this is way simpler than you think. It all starts with the keyword class. That tells Python we're making a blueprint. Then we give it a name, like student. And pro tip, by convention, we always capitalize the name. Then you add a colon, which just means, okay, here come the rules. And for now, we're just going to write pass, which is Python's way of saying, we'll fill in the details later. It's empty for now, and that's totally cool. So what did we just accomplish? Well, we have a blueprint. It officially exists in our program, which is awesome. But it's also completely empty. It doesn't know anything about data like a name or an age, and it certainly doesn't know how to do anything. It's a perfect, valid, but empty shell. Now for the really fun part. We have our blueprint. Even if it's empty, we can now use it to start manufacturing actual, individual, student objects. Creating an object looks a lot like calling a function. We'd write something like Ali equals student of. So on the left, Ali is just a variable, a little box to hold our new student. On the right, we use the class name, student, followed by parentheses. And those parentheses, that's the magic. That's the command that tells Python, hey, go find that student blueprint and build me a brand new object right now. Now, what's really, really important to get is that every object we create is completely independent. We can make Ali, we can make Sarah, we can make Ahmed, all from that same student class, but they are three totally separate things. It's like having a mold to make toy cars. You can make 100 cars from the one mold, but if one of them rolls off the table and breaks, the other 99 are perfectly fine. So if you actually try to print one of these new objects, you might see this really weird-looking text on your screen. Don't panic. That's not an error. That's actually a good thing. It's just Python's super technical way of confirming, yep, I did it. I successfully created an object from your student class, and I've stored it at this very specific address in my memory. It's proof that it worked. Okay, so we've got objects, which is great, but right now they're just empty shells. They're not very useful. The next logical step is to figure out how to give each student their own unique information, like a name and an age. And that brings us to a really important question. When we create Ali, how do we make absolutely sure that the name Ali and the age 12 get attached only to him and not to Sarah? The answer involves two special and sometimes tricky concepts in Python, init and self. First, there's init. You'll see it written with these double underscores around it. The easiest way to think of this is as the object setup function. It's a special method you put inside your class, and the magic is you never have to call it yourself. Python runs it for you automatically the very instant a new object is created, which makes it the perfect place to give our object all its starting data. And now for the secret ingredient, self. Inside the class, self is a special variable that always means the specific object we are working on right now. So when our code is creating the Ollie object, Python automatically passes Ollie into that setup function as self. So when the code says self.name equals Ollie, it's really saying Ollie.name equals Ollie. It's the critical link between the general blueprint and the specific object. So what's the result of all this? Well, when we create Ollie with the name Ollie and age 12, and then we create Sarah with Sarah and age 11, that self variable makes sure all the data goes to the right place. Ollie's data is stored with Ollie, and Sarah's data is stored with Sarah. They never, ever get mixed up. Awesome. Our objects can now hold their own unique data. But objects are more than just fancy containers for information. The real power comes from the fact that they can also perform actions. Let's make our students actually do something. So to add a behavior, we just define a function right inside the class. And a function that lives inside a class gets a special name. We call it a method. And notice, it also takes self as its first piece of information. That's so the method can access the object's own data, like self.name and self.age, to do its job. So now, when we call ali.introduce, Python knows exactly what to do. Because of self, that method has access to Ali's specific data. It prints his name and his age. And if we were to call Sarah.introduce, it would use Sarah's data instead. Each object acts on its own behalf. It's fantastic. Phew, we've covered a lot of ground, from blueprints to data to actions. Let's tie this all together into one simple, powerful mental model that you can carry with you from now on. Just think of your class as a factory machine. It's the design for making things. An object is the actual product that comes off the assembly line. The underscore init method, that's the setup process on that assembly line. It's where each product gets customized as it's being made. And self, that's the unique made for Ali or made for Sarah label that gets stamped on each product, ensuring it belongs to them and them alone. So you've just built a complete model for a student, all the way from the blueprint to a functioning object. The real question is, what's next? I mean, think about the world around you. A car, a bank account, a playlist, a character in a video game. What other real-world blueprints could you design and bring to life in your code?